Hello, my name is Alana Scoggins, and I'm a freshman at Clemson University Honors College, where I am pursuing a major in microbiology with a concentration in biomedicine. Over the summer, I was able to work with Dr. Carrie Smith, who is researching genes involved in acetate utilization in the fungal pathogen Cryptococcus neoformans. Cryptococcus neoformans is a fungus that is naturally found in the soil and causes cryptococcal meningitis, which can be fatal if not treated quickly. The CDC estimates around 220,000 cases of cryptococcal meningitis each year, resulting in about 181,000 deaths. Cryptococcus is an opportunistic pathogen, meaning that it mainly affects immunocompromised individuals, especially the AIDS community. The vast majority of cryptococcal meningitis cases occur in sub-Saharan Africa, which is where the highest number of HIV and AIDS cases occur, and where there is limited access to healthcare. The current treatments for cryptococcal meningitis include 5-fluorocytosine, amphotericin B, and fluconazole. The usual course of treatment is a 2-week IV treatment of 5-fluorocytosine or amphotericin B, and up to a year-long treatment of oral fluconazole, which is not always effective and must be started early in infection. This treatment is hard to complete in developed nations, and it is near to impossible to complete in sub-Saharan Africa and other developing nations where there is little access to healthcare. To combat this problem, researchers are trying to develop a more effective treatment for cryptococcal meningitis based on genes that are involved in the virulence of Cryptococcus neoformans. For our research project, we worked to identify genes in Cryptococcus neoformans that are involved in acetate utilization. Cryptococcal infection starts in the lungs and then spreads to the brain. In the lungs, defense mechanisms called alveolar macrophages capture Cryptococcus spores. Cryptococcus must have access to a carbon source to survive, and it prefers glucose, yet these alveolar macrophages are a glucose-poor environment. Instead, they are rich in acetate and other non-preferred carbon sources. Therefore, we have hypothesized that genes that are responsible for acetate utilization help establish cryptococcal infection and therefore contribute to its virulence. Previously in the Smith Laboratory at Clemson University, a screen was conducted to determine which genes in Cryptococcus neoformans are required for the fungus to grow on acetate. I looked at gene CNAG 00236, which has been determined necessary for the fungus to grow on acetate. I used FungiDB, a fungus database, to determine predicted protein functions of the enzymes coded by CNAG 00236. I also used transcriptomics graphs, which measures the number of transcripts per million of certain genes from this database in order to determine under which conditions CNAG 00236 was upregulated, and this will hopefully help to determine the possible protein functions of the gene. The Smith Laboratory has also determined certain genes that are expressed more on acetate than on glucose, but these genes have not yet been determined as necessary or not for the fungus to grow on acetate. So I looked at 3 of these genes: CNAG 05310, which is a NIP-SNAP family protein, CNAG 07403, which is a peroxisomal ATPase, PEX1, and CNAG 03697, which is a hormone-sensitive lipase. And I tried to determine their protein functions based on the FungiDB database and the transcriptomics located there. Looking into the protein functions of these genes gives us more insight onto whether or not the gene affects the virulence of Cryptococcus neoformans. The goal of the project was to find out any new information about these genes, and the hope was to find a link between one of the predicted protein functions of these genes and acetate utilization. In the future, these identifications will hopefully be able to aid researchers in finding a targeted and effective cure for cryptococcal meningitis. Thank you so much for listening.